Hello and welcome to the Allplane Podcast, here with the people that are redefining the future of commercial aviation. And as usual, before I introduce today's guest, the usual reminder that you can find all the previous episodes of this podcast, as well as many other aviation stories, on the Allplane website. That's Allplane.tv, Allplane.tv. Today we're back to one of our favorite topics, electric aviation. Our guest is Marc Ausman, founder and CEO of Airflow, one of the startups that are farther down the road when it comes to developing a viable electric aircraft. Marc has made quite a career at the intersection of aviation and technology. After flying P-3 maritime patrol aircraft for the US Navy for a few years, he went on to work for a number of technology startups. He even built and sold an aerospace technology firm before joining the Airbus Vahana project, which a few years ago was one of the pioneers in the eVTOL space. Actually, quite a few people that work at the Vahana project ended up creating other startups in the advanced air mobility space. And one of them is Airflow. At Airflow, Marc and his team have opted for an eSTOL concept that is electric short takeoff and landing, starting with hybrid propulsion with the idea to later switch on to fully electric flight. The aircraft they are developing should make it financially and operationally feasible to fly both passengers and cargo to and from thousands of runways that are currently underused. The idea has already been endorsed by some 15 customers that have placed orders for Airflow's 9-seater aircraft. But let's not get ahead of ourselves here, and let me welcome Marc to the podcast. Hello, Marc. How are you?
Good afternoon. Great to talk with you today.
Well, good afternoon for me, but good morning to you because you.
Yes, absolutely.
I'm in Europe, but you are 9 hours behind and in California,
Yes.
right, in the Bay Area.
Yes.
Great. So let me first introduce you very briefly. You are the founder and the CEO of Airflow, which is a very interesting startup in electric aviation. But like every other guest, I just want to ask you to introduce yourself. After that, we're going to move on to your project and your technology and what you guys are doing. But just give us a little bit of a feel about your background and your connection to aviation.
Yeah, Mikhail, happy to do that. I've been around aviation my whole life. It's very, very exciting space. My father was an airline pilot. My mother was a stewardess. And when they got married, they had a few kids. And so I was the oldest child. And, my dad flew commercially, of course, but he also had a Bonanza, which is a small piston-powered single-engine aircraft. And so we would go out and fly that on occasion. And his friends were pilots as well, too. And so we would go to lots of air shows and fly-ins and things like that. So, I ended up getting my pilot's license in college and then went on to the Navy to fly P-3s. And the Navy ended up being based out of Barbers Point, Hawaii, which is now closed. But at the time was, of course, a great duty being on Oahu for my first tour. And then we did 2 deployments from there to the Middle East during Desert Shield, Desert Storm, and then another deployment after that.
So you know the oceans as if it was your home, pretty much. You know the Pacific Ocean like as if it was your living room.
Well, yeah, it all kind of looks the same after a while. You can fly for a lot of hours and still see ocean. But yeah, we flew in the Pacific Ocean and the Indian Ocean is where we spent most of our time. And as the Navy, we fly mostly feet wet, meaning we fly over the water. We don't do much flying over land.
Chasing submarines.
And when I joined the Navy, with Glasnost, and the Russians had basically parked all their submarines. And I think they've been parked until just recently, but they parked all their submarines. And so, in finest military fashion, we were looking for something to do. And the P-3 is actually a very capable airborne radar platform. It can stay on station for 12 hours. And we have some really interesting technology on board the aircraft for targeting and for searching for different vessels on the ocean. And so we did we trained for prosecuting submarines, but we also trained for what's called over-the-horizon targeting, which is where we would go search for vessels in the sea, and then we had weapons on board that could target those.
And now we have all these. Now we have all these applications like marine traffic.
Well, the people we were looking for didn't generally report their position over the internet. So
I can guess so. Yeah.
yeah. But that was exciting times, flying around the world in a plane with a crew of 12 people, and then after the Navy. Is kind of a transition to civilian life. Went to grad school for 2 years and got an MBA in Texas, and then actually worked in the tech industry for 7 years as a product manager for various enterprise software startups, and that was pretty exciting. But really always wanted to find a chance to get back into aviation, and wasn't really too impressed with the innovation going on in the industry. It's very, very incremental and very, very conservative approach to new technologies. And it's understandable that that's the approach that the industry takes because safety is key. But had the opportunity to go work with Eclipse Aviation, which brought to market the world's first very light jet. And that was started by actually an early Microsoft employee. So, the idea was to bring kind of this tech mindset to the aerospace industry and disrupt the aviation industry and change the economics of travel, and therefore changing the way that the ability to travel and to bring costs down to a way where people would start thinking about using air travel, and specifically regional air travel, rather than driving, or using cars or trains or something instead. And in Europe, trains are very popular. In the US, they're not so popular. So the main competition for regional air travel is either cars or aircraft. And today, aircraft are way more expensive. And what we were trying to do at Eclipse at the time was to bring that cost down so that air travel would be an option. And it was enabled by a new technology, specifically a very small turbine engine that turned out didn't actually work as advertised, but that was the promise, was this small turbine engine could revolutionize air travel. Today, we see that same dynamic, but the technology enabler is electric propulsion. And so it's kind of Eclipse 2.0 in many ways. You could debate that all day, but I see a lot of similarities. We see things like high volume manufacturing. We see greatly reduced operating costs. And we see the ability for people to travel outside of kind of these major airline hubs, either with, today with vertiports or with smaller airports that are underutilized today. So,
Go ahead.
Well, yeah. So I was just going to say that was really an exciting opportunity. And then actually after that started a company to make avionics for small aircraft and sold that about 7 years later, and then consulted for various different very early companies doing autonomy, doing eVTOLs, and ended up with something pretty exciting, which was the Airbus Vahana program. And that was a technology demonstrator, or let me back up just a bit. Airbus had set up a Silicon Valley outpost to explore new technologies on a project basis. And one of the projects in this outpost was called A Cubed, and A Cubed had several projects going on at one time. One of the projects was the Vahana program, which was an electric VTOL, or vertical takeoff and landing aircraft. And it was a technology demonstrator. It was the first time Airbus, or for anybody for that matter, had really flown an electric vertical lift aircraft with multiple rotors and electric motors and pure battery electric aircraft. So it was very exciting, very successful. And those learnings were transferred back to Airbus when the program wound down. So that was really the genesis of Airflow at that point.
Yeah, actually, this Airbus Vahana, it didn't really consolidate into something long term, but actually it was a sort of I don't know if it's the right word, but not a school, but it gave to the industry a whole generation of people, of entrepreneurs that are now in a whole range of different companies and doing impactful things.
It is. We left and started Airflow. There's people who went over to Archer. There's some who went to Joby. There's some who are at Overair. So really, a lot of experience that we gained on that program, people have taken to other programs, which are generally startup companies. Yeah. And you'd said it never made it into production, and it's kind of a lot of confusion in that area. It was never really intended to be a production aircraft. A Cubed is to explore new technologies that really don't fit into the normal P&L responsibility of the other business units within Airbus. And so there were all these different kind of exciting programs going on and exploring new technologies. In our case, our goal was to design and build and fly this aircraft. We flew over 140 flights, and through the whole envelope. And I think the last flight was about 30 minutes. And it really, just all the learnings from that went back to Europe. You can imagine that the future of a sort of vertical lift aircraft for Airbus isn't going to happen in Silicon Valley. It's going to happen in Europe.
Yeah,
and so
actually,
the learnings.
yeah. No, I was just wanted to clarify. I was not very accurate in the description, because actually Airbus hasn't given up on this concept. It recently presented an eVTOL concept as well. Just want to say it didn't crystallize in. I mean, it didn't have a continuity as such. So as a Vahana was under the label Vahana, it just had continuity, but in different ways.
Yeah. So along with Vahana in Silicon Valley, Airbus was also running something called City Airbus out of Donauwörth, Germany, which was another multi-copter approach. So there was these two different programs that were meant to explore this new technology and the use of electric motors and batteries for vertical lift aircraft. Then I think the learnings from both of those programs, and we're, I'm not involved with this anymore, so I can't give any specific details, but, the learnings from those programs basically informed Airbus's decision about this program that they announced recently. And I believe that intention of that is to move forward as a production aircraft.
Yeah. No, definitely. That didn't come out of nowhere. There's this whole experience of many years working in this field.
Right.
So Airflow, you then after Airbus started Airflow straight away, or what's the story?
Well, I spent some time exploring after Airbus, exploring where the opportunities were. I think the key thing that the learning from the Airbus program was that, eVTOLs, or electric vertical takeoff and landing aircraft, represent only one of many, many opportunities to introduce electric aviation to the aerospace market. And while there was a lot of hype, and I got to say, Uber at the time, Uber had Uber Elevate, which was a program to promote the use of electric VTOL aircraft to move people around cities. They did a wonderful job of really bringing a lot of attention to this space. And, everybody jumped into this, and everybody said it's got the huge market opportunity, and a lot of startups, raised money based on those reports, and Uber was going to be a customer.
And many professionals as well that went through that project. Actually, one of the most recent podcasts I did here with a battery expert, we talk also about Uber Elevate, because he had also been in touch with some of the guys involved there.
Yeah. No, I think they did a great job of really catalyzing the investment community and the industry and everybody around this idea of electric vertical takeoff and landing aircraft for this called urban air mobility mission, or moving people around cities. And using airports, or mostly, the tops of skyscrapers or buildings, or vacant land in cities, if there is such a thing. And so they really did a great job of catalyzing it. Ultimately, Uber, had other priorities that they had to sort out and drop the program. But again, that was another program where the people from that, from Uber Elevate went into industry and are, kind of scattered about, but have, brought a lot to the table in terms of moving the thinking and moving the industry forward. So that was really great. But the downside of that, or I don't know if downside is the right word, but one of the side effects of that is that everybody was focused on this one specific use case. And in fact, there's many other use cases for electric aviation and moving aviation in general to a more sustainable future, and to building aircraft with capabilities that really don't exist with traditional aircraft. And when we realized that there were these other use cases and other types of aircraft that we could develop and make better with electric aviation, that's when we started Airflow. And the use case that we've ultimately settled on is the use of a eSTOL, or electric short takeoff and landing aircraft, which is a fixed wing aircraft, looks like a very conventional aircraft, but has a lot of smaller electric motors with propellers along the front of the wings. And that type of aircraft can be used to fly from airport to airport within regions. And we define a region as typically less than a 500-mile flight. And so, as you may know, around the United States and around the world, there's a ton of these smaller airports. And many are very, very much underutilized. They're not utilized at all by the airlines or commuter airlines or anything. And so they don't get a lot of activity, but they're great assets that can be used for the transportation infrastructure. The challenge is there haven't been aircraft that really are economically viable to make that model work when you fly into these smaller airports. And we believe that electric aviation ultimately will make great use of these underutilized assets in the United States and throughout the world, by bringing down the operating costs, by moving to quieter operations, and by moving us all to a more sustainable future.
you've been sort of an evangelist for this type of model. I mean, you've got some interesting blog posts on your website. I'm gonna post a link when you explain
Okay.
the differences in the short haul regional electric flight or with conventional takeoff and landing. Well, eSTOL, so short. I mean, you require less runway than a
less runway, but you can think of it as a CTOL or conventional takeoff and landing as well. The only difference really is the length of runway you can get into. But they're both intended to be used primarily off of airports and not helipads. Right? The VTOLs are primarily used for helipads. And you know, we look at what we're doing with the fixed wing aircraft and what others are doing with the VTOLs is very complementary. They're two very different mission sets, and one of the blogs outlines that. Basically, we say that, you know, eVTOLs have the unique capability of VTOLs is that they can take off and land vertically, which means they can take off and land in very small space. Although we require a very short runway, you still can't, you know, still putting a runway on top of a building is different than putting a helipad. And so we think that, you know, the VTOLs are great where you actually have a mission where you do need to take off or land on top of a building in a very small space. In our aircraft is best utilized for use cases where you in fact do have airports or very, very short runways. The main difference between these two is the operating costs. So anything with vertical lift capability will always cost more to operate and you know, than a fixed wing aircraft. And so we can do it for less cost, but we need to do it between airports. If you need to take off and land from buildings, that's great. Use VTOLs for that purpose. You're going to pay a little bit more for it, actually quite a bit more for it, but nevertheless, it's a great capability to have. And so the two types of aircraft are very complementary in that regard. And once you realize that, you know, that you know, that's what we realized early on, and said we don't really, you know, moving ahead with an eVTOL is a use case, but there are other use cases that we want to go after as well. And so we took a little bit of a different path than the hype around the industry was at the time, and still is for the most part.
This is going to be 100% electric, or you are also considering hybrid versions?
Our first aircraft, our first aircraft will be a hybrid. Think of it like a Prius, and the Prius was out, you know, 15 years before the Tesla Model S. And so you get some benefits with the Prius as a stepping stone to getting to full battery electric. And for very short range flights like eVTOLs are targeting, you know, or like, let's say 50 miles or less, an eVTOL makes a lot of sense. And most eVTOLs are being designed as a pure battery electric solution. That's fine because their range is about 50 miles max. Once you consider all the knockdowns required for commercial service and flight planning. For what we're doing, when we say regional flights, up to 500 miles in all weather conditions with de-ice, with IFR reserves, meaning extra reserves required by regulations in order to fly in bad weather. And you do need to be able to fly in bad weather to have reliable commercial service. And so in order to do that, today's batteries just are not there, just full stop, just can't get there. So we have to adapt a hybrid electric solution, and that will allow us to develop an aircraft that is really, we believe, commercially viable, have better performance, lower operating costs than today's comparable existing aircraft, and be able to open up this regional air mobility market.
I'm going to post some renderings and links on the show notes, but just to give a very brief description of the sort of aircraft we're talking about here, is a 9-seater.
Correct.
So it's 9 passengers plus the crew?
Plus the pilot, yes.
One pilot.
One pilot is required. A lot of these commuter airlines and regional airlines fly with 2 pilots.
Okay. And you have, that's interesting, it's a distributed propulsion. So that means you have lots of small electric motors all over the wing. So it's a high wing with these motors. What advantages does this technology bring?
So this is called blown wing technology. And the way we're achieving blown wing technology is with something else called distributed electric propulsion. And blown wing technology has actually been around for decades, and it's been tried by NASA and others in the past. And the challenge is that with turbine engines or piston engines, it ends up being a very, very complex, mechanically complex system that isn't commercially viable from a cost or reliability perspective. And so it never really made it past the R&D stage. But once you have electric propulsion, you can actually, electric motors are very, very reliable, very simple, run at very low temperatures. And so you can, and it also scale up and they scale down in a very linear fashion in terms of power versus weight. And so we can put small electric motors along the leading edge of the wing. And that allows us to blow the wing and basically, blow the air over the wing rather than having to move the whole aircraft with the wing fast enough to do that. So the blown wing technology is now, with distributed electric propulsion, is now that technology allows us to implement blown wing technology in a commercially viable manner where it's reliable, it's cost competitive, and it actually works really, really well. And so what that allows us to do is it allows us to design an aircraft with a wing that is much smaller than a normal wing would need to be. Therefore, in cruise, it's more efficient because it's smaller. And at low air speeds, we just blow air over the wing to get more lift. And so we achieve more lift with a smaller wing. Normally, a wing that small couldn't hold up the aircraft at low air speeds. The airplane would stall. But when you blow air over the wing, then you get more lift and you can use that smaller wing. When you have low air speeds, the ability to fly slowly, you can then approach a runway and land at a lower airspeed, meaning you can stop more quickly as well too. The other benefit is with the smaller propellers. So if you have a disc that's, say, 6 feet across versus a disc that's 3 feet across running at the same RPM, the tip of those propeller blades will be at a slower speed than on the smaller disc than on the larger disc. And so if you have one propeller on the front of an aircraft versus a bunch of smaller propellers, you're going to have lower tip speeds, and that's what generates the noise. It's one of the things that generates a lot of noise is the tip of the propeller. So when you run the tip of the propeller at lower speeds, you have less noise. So we also, plus the electric motors and everything get you lower noise overall too. So all these factors contributing to lower noise, better performance, meaning lower approach speeds, higher cruise speeds than a traditional aircraft. And then the third aspect is once you have electric motors, they don't really care where the energy or the electrons come from, right? So you can have a turbo generator, which is like the Prius kind of approach, which is what we're doing now, because that's really the only commercially viable approach.
So that's jet fuel driving the generator, right?
It's jet fuel or sustainable aviation fuel, depending on what the operator wants to run. So we can get the check in the box for sustainability with a turbo generator by running sustainable aviation fuel. And when I say we, I mean our operators. We don't operate the aircraft. We sell it to people and companies and operators that do fly the aircraft. And then we've also partnered with Plug Power. And Plug Power is a publicly traded company that's been in the hydrogen business for a couple decades now. Really has some great fuel cell technology.
Yeah, I wanted to ask you about that deal because I remember reading about it.
Yeah, well, we can now. So let me talk about the technology and how we're applying it, and then Plug Power. But we can take out the turbo generator, and I'm simplifying greatly, of course. But you can take out the turbo generator, and then you can plug in a hydrogen fuel cell, and generate electrons with the fuel cell. And then ultimately, we believe at some point in the future, when batteries evolve, we'd like to take out the hydrogen fuel cell and put batteries in there. Or run the hydrogen fuel cell for other use cases. You'll probably always have longer range with the hydrogen fuel cell than you will with batteries as that technology improves too. So so both of those are sustainable solutions, and I think that there's all kinds of other considerations around batteries and hydrogen, but we won't get into those here. But let's just assume that kind of the front end of those and the back end, meaning the creation of the batteries and then the recycling part of the batteries, or the electrolyzing the hydrogen and all that, that will all get better over time and more efficient, and we'll kind of sort through that. Our responsibility is really to figure out how to utilize those in aviation itself.
What about the cost? Because we are under the assumption that this is going to be cheaper to operate than today's conventional aircraft, and that's what allows for this more distributed mobility. What order of magnitude in terms of cost savings, operational cost savings, we're talking about here?
Well, we're taking this incremental approach to the market, because if we went to a pure battery electric solution right away, which we could and would actually technically be easier to do, we wouldn't be able to sell many of the aircraft. It just wouldn't have the range and capabilities that our customers need today. So there's very limited use cases for a pure battery electric, regional aircraft. Like I said, a VTOL that flies short range, great for batteries, but for longer regional flights, there's very limited use cases. And so we believe the best way to move to a sustainable future is to take this incremental approach, where each approach is commercially viable at the time that that technology is introduced, right? If we introduced something that was, like I said, a pure battery electric solution, we just wouldn't sell many of them. I don't think it would ever really get a lot of traction. Mm-hmm. And we know that because we've talked to a lot of companies who operate aircraft, and they just say, it's a non-starter. So the hybrid is the first step there, and we believe that the hybrid electric solution will get about a 30% overall cost savings. Mm-hmm. And it comes from multiple different factors, but the overall 30% cost savings. And then if we look ahead, say 15, 20 years, when we can take the pilot out of the cockpit and move to an autonomous aircraft, when we will have batteries that are low cost and high energy density, and that makes sense, we can save as much as 70% over today's operating costs. Yeah. And so if you look at this path over the next, say, 20 years, moving from 30% savings, when the aircraft is released, to 70% when there's some new technology and some change in the regulations, that change over time really is going to drive this movement based primarily through lower costs to getting people to fly rather than drive. And that means removing congestion from the roads. That means saving time. And just flying is pretty damn cool, being in the air and getting the view. And, we're not going to be flying at 30,000 feet. We're going to be flying at a few thousand feet over the ground. People will be much more connected to the environment around them. And flying into these small airports that are right near where you live is going to be an amazing experience.
I wanted to ask you about this point, because I guess you are planning, your business model is to be an OEM, to make the planes and then sell them to operators.
Correct.
What type of operator are you envisaging here? Are you thinking about existing local or regional carriers? Are you expecting new operators that will spring up to service this new demand?
Well, we're not just envisioning. We have 15 customers today who have signed letters of intent, and they have all indicated interest in this type of aircraft.
15. Wow.
15, yeah. And we haven't announced most of them, but we've announced a few. They're up on our website in the news page.
For how many aircraft in total?
I can't really announce that right now. Okay. I think we've announced part of the orders. We haven't announced all the orders, but
okay, no problem.
That's all coming out in due time. But the point is that we looked at early in the company's life. We looked at multiple different markets, and we're not able to get LOIs from other markets. They just weren't ready to sort of commit to this new way of doing things. So we what we learned was that the market entry strategy is to really take the path of least resistance. How do we fit into the way things work today, right? And I learned this kind of back from my enterprise software days. Is if you want to sell enterprise software into a company, you got to sell it, and it's got to fit in with the systems they already have in place today. Yeah. Like you can't go in and expect them to set up a whole new infrastructure just to run your software. So if you fit into the way things work, it's much easier to make a sale. Yes. And so that's really the key things. Now on the and so those certain markets really weren't interested in moving in this direction quite yet, but the customers that we do have are in the regional charter market. Basically, they fly aircraft today, and they they have kind of these scheduled operations. So they have kind of places where they normally fly, and you say, I want to fly here today, and they'll take you there. Some offer per seat scheduled flights. Some offer you can charter the whole aircraft. But the point is, most of our customers fly aircraft today. They fly really old and great aircraft like Beavers and Otters. They fly, when I say newer, this is a 40-year-old design aircraft like a Cessna Caravan, kind of a workhorse, aircraft in the industry. The logistics industry uses it a lot for regional air cargo.
You even sold an amphibious. You even sold an amphibian version, right? For Tailwind Aviation in the East Coast.
Yes, and so Tailwind, for example, flies caravans today with floats, and the Beavers have floats, Otters have floats. So these types of aircraft are designed in a way that you can take the landing gear off and you can put floats on. And there's what are called straight floats, which are just floats that only work in the water. And then there's amphibian floats, which actually have retractable landing gear in them. And you can raise and lower the gear so you can take off on the water and land on an airport somewhere. Very, very flexible. And so we're going down that same path where you can put tires and wheels and tires on it for traditional airports. You can put bush tires on it for backcountry flying. You can put floats on it for water flying, either straight floats or amphibs. And so the airplane has a lot of utility and a lot of flexibility. We're also designing it primarily as a cargo aircraft. And there's some very interesting aspects about the way cargo has evolved over the last decade or two. That really doesn't, the industry's changing in a way that the older aircraft don't really work too well for cargo, even today and looking forward. So our aircraft incorporates some design features that really are forward thinking in terms of the cargo industry. But what that means is you have a very spacious cabin for passengers as well too. You just got to put some windows and a nice interior in it, and some seats, and you end up with a great passenger aircraft as well that can fly these missions.
Yeah, I checked on your website. Says it can carry, in a cargo configuration, it can carry 800 or 900 kilos, something like that.
Right, no, about 900 kilos or 2,000 pounds of cargo.
Yeah,
and we're actually, that's evolved. It's ballpark, but somewhere in that range. We're actually doing some deeper analysis to refine that figure. But ballpark, about that number.
About a ton, just to round it up a little bit.
Yes, exactly. A ton, 2,000 pounds or so of cargo, and 900 kilos, and that's really where we found the sweet spot. And the reason there's a sweet spot there is because the regulations, at least in the U.S., and it kind of varies around the world a little bit, but for the most part of the U.S., you Part 1. So these operators that I told you about earlier, the ones who are customers, are classified under what are called Part 135 operators. That means Part 135 of the Federal Aviation Regulations describes how they need to run their business in order to collect money to carry people and cargo in aircraft. And those regulations stipulate that you can only carry maximum of 9 passengers. And if you want to go above 9 passengers, you end up with a whole different, more complex set of regulations. And so the 9-seat market is kind of where the industry has evolved to support that.
Obviously, you're designing the plane. Are you going to manufacture it as well?
We are designing it, and we are going to build it. Now, when we say build it, that could mean a lot of different things, right? And the question is, how vertically integrated are we in terms of building it?
That was my question. Yeah.
And I think it's too early to really dive into the details of that, but I'll say that, as an OEM, we have some decisions to make around that thing. There's a lot of companies in the US and around the world actually that will make, substructures, or, make a fuselage or make a wing or make a tail section or something like that. And so I would say at minimum, we're going to be assembling substructures that we get from other companies. At most, we'll be building all the structure ourselves and then putting into it the motors and the batteries and the other components, avionics, and other systems that come from various suppliers around the world.
Yeah, even like the large jets, like Boeing, for example, they also have plenty of subcontractors making big parts of the jets as well. So
yes, it's very common. Yes. If you look at Boeing, their facility like up in Everett, and they have another one on the East Coast. Yeah, they assemble. I don't want to trivialize it. It's certainly a lot of work and very skilled people doing the work. But they assemble sections of aircraft together. And they get the landing gear in from somebody, and they get a fuselage section in from somebody else, and a tail section from somebody else, and the avionics come, and they put it all together, and it's a pretty amazing manufacturing operation. But that's sort of what they've decided to do.
Tell me about the company.
Airflow is based in the San Francisco Bay Area, and it was founded by five people who we all met on the Airbus Vahana program.
Okay.
And we all recognize the challenges in opportunities of the eVTOL market, and all thought that there was there are other ways to bring electric propulsion to market that we think actually have a larger market opportunity, that have a more well-known and well-defined market opportunity. In other words, the market exists today. when you look at the VTOL market, the market actually doesn't exist today. There is no market for helicopters moving in between buildings and cities. Sao Paulo, Mexico City, there's a little bit of that, but for most U.S. cities and European cities, it's very, very, either is banned outright or is very limited traffic due to cost.
Yeah.
And so we think that that's a very speculative market, and we think a better approach to bring electric aviation to market is by fitting into the way things work today.
Mm-hmm. Yeah, I read a couple of articles, well-documented articles that were making this point, actually, written by independent analysts that, we're a bit skeptical about the eVTOL urban air mobility market. Then I know, there's other operators, other analysts that have a different opinion, that are very, very bullish. But there's certainly a high level of risk that's undeniable in this development of this market. Yeah,
certainly an exciting opportunity. I hope it goes well. I don't have any crystal ball that's different from anybody else's crystal ball. So, all I have is my opinion, and those are there are many of those out there today.
Yeah.
So all we can do is say, like, the people who are doing that, let's support them. Let's see how this goes moving forward, and hope it prevails.
Yeah, and I wanted to ask you also about another aspect of your project. Here on the podcast a few months ago, I had a conversation with Lucas Kessner from Germany, from the Sustainable Aero Lab, and I think you participated in their program, right?
We did
the startup program. So what was your involvement with Sustainable Aero Lab? I was just curious.
So they have a process that they take, startup companies through. And the reason we did Sustainable Aero Lab was that we wanted to get some more exposure and introduction into people in Europe. And it's based out of Hamburg, Germany. And you basically just meet on a regular basis and talk about progress and get feedback and other things like that. So it's very low touch. It's very easy to do. You don't have to go in every day and do, they don't ask for equity or it doesn't cost anything. So it's very easy to do, and they bring in some great people from all around the industry, from all around the world. So I would say, the key benefit of that was really getting input and perspective from different people who work in different parts of the industry from all around the world, and then being able to meet these kind of people and make introductions and that. So I thought it was a very worthwhile effort, and I would certainly recommend it to any other startups doing any kind of sustainable aviation startups. And by the way, they don't just do aircraft OEMs. As a matter of fact, I think the majority of
they do
what they do is not aircraft OEMs.
All sorts of technologies,
enabling technologies and different aspects of aerospace. And what's really, really exciting though is this point in history right now that we're seeing more money, more interest, more people coming into aerospace. It's generally been, you don't see that much sort of industry. It's been a very insular industry where it's kind of the same players kind of doing very, very incremental stuff. Not a lot of new people come in, and it's primarily because it's a highly regulated industry and there really wasn't an opportunity for change. It was kind of the same technologies moving forward. Right now with electric propulsion, I think there's really an inflection point in the industry where new players can come in and really introduce some new exciting stuff. There's a combination of autonomy, technology, kind of, machine learning, all that being smart enough, kind of really coming together. It's a perfect storm of, that's one aspect of it. Electric propulsion is another aspect. Those two technologies don't have to be linked together. And just a whole lot of capital coming in to support this, and interest in sort of this next generation of mobility, recognizing that, cities are clogged, that traffic is an issue, that people want to move around. Mobility is really a big thing. And if aerospace can really contribute to that, and recognizing we have this massively underutilized infrastructure in the US and around the world, that perhaps electric aircraft could in fact provide a way to utilize those in an economic and commercially viable manner, that would be great. So it's really, really exciting. I started a company in 2006. I think I mentioned it earlier, but it was making avionics for small aircraft, and nobody was interested in investing in aviation stuff at the time. Like, it was really hard to to get people interested in this business. But now it's quite the opposite. There's, as you know, tons of money coming in, and there's lots of interesting ideas and different technologies. And we're looking at new air traffic control stuff. Drones are driving a lot of this, smaller drones to move, do deliveries and imaging and other kinds of things. So you have this confluence of all these different things coming together, and investors being interested in the space. That really is making for an interesting time in the industry, for sure.
Yeah. And I don't know are there any specific, let's say, next milestones you can comment on at this point? Anything that we should be keeping an eye on?
I can't say anything other than stay tuned.
Okay.
Yeah.
Great.
Yeah.
Yeah, well, I'm definitely I'm following. I'm following your channels. Where would you send people that would like to learn more about Airflow and to stay on top of what you guys are doing? Any websites, social media channels, this type of thing?
So LinkedIn, Airflow.aero has a LinkedIn page, and we post up there on a regular basis. We also have a newsletter we send out perhaps once a quarter. So if you go on our website, there's a way to sign up for our newsletter. And then just go visit our website at Airflow.aero, AERO. And there's a news page. You can see recent news announcements. There's a blog where we share some of our thinking on the industry. And then just the latest information is there as well. So.
Okay, well, thank you so much for your time today. And definitely, as you said, exciting times for everyone that is following the aviation industry. And so wishing you all the best with the project. Hope to see many of these environmentally friendly and cheap aircraft flying soon.
Yeah, thank you very much. Appreciate you having me on the show.
Pleasure. Thank you very much. Before you go, and if you like this podcast, a quick reminder that it would be absolutely great if you could please give it a rating on Apple, Spotify, or whichever platform you're using, or recommend it to a friend or whomever might be interested. Thank you very much, and see you soon.